Good day, guys. Welcome to GS Academy, and our topic for today is on integral calculus. So now, integral calculus is divided into two parts. So we have our indefinite integral and our definite integral. Now, how do we know which one is our indefinite integral and how do we know which one is our definite integral? Now, looking at these two expressions here, we are told to find the another name for integral calculus, you can call it antiderivative, or you can also call it integration. So now, you know that this is an indefinite integral because there is no limitation as to where the answer can give you. Are you with me? Your answer will always be in form of an expression, or rather it give you a constant. But for this, your answer will always give you a constant. So now see the difference. We were being told that your answer should be in between 2 to what 0. But for here it is just what indefinite. That is why whenever we integrate and we get our constant for our definite integral, our constants will eventually cancel out each other, therefore giving you what? A real answer. Now, if you are asked to integrate ax to the power of n dx, that is, you are told to find the antiderivative. How do you do so? Note, this our a here is a constant. You can easily bring it out, similar to the way we did our differentiation. So you are left with what? X to the power of n. Now, this will be what? A times. If you have to integrate this, it will be x to the power of n. Remember, I said antiderivative, which means when you are looking for the derivative of an expression, we minus one and the times. But this time around, we'll be doing the reverse. So we'll be adding 1 over. Note, in our differentiation, we multiply, but here we'll be dividing. We'll be dividing by what? The sum of the what? Power. Then what do? You add our what? Our constant. So we can say this is ax to the power of n plus 1 over n plus 1 plus our constant. So in some textbook, they might tell you it is k. Regardless, whether c or k, they'll still be giving you the same answer. Now let's solve a real question. If you are given x to the power of 4 dx, and you are told to find the antiderivative of this, then what do you think will be the answer? It will be x to the power of 4 plus 1 over 4 plus 1. Remember, you always add your constant. Therefore, this becomes x to the power of 5 over 5 plus c. This is our final answer on this. Now, let's solve another question that has to do with we adding a constant or wherever we have a coefficient attached to this. So now, if you are given 16x to the power of 3 plus what? C. I are told to find the dx. I are told to find the antiderivative of this. You can easily bring this 16 here, then you find the antiderivative of what? X to the power of 3. Remember, we have our dx. So this will be what? 16. Let's open our brackets. This becomes x to the power of what? 3 plus 1 over 3 plus 1. Close brackets. Then we do what? We add our c. Now, this will be 16 in brackets, x to the power of 4 over what? 4. Close bracket plus c. This can cancel this. 4 here 1, 4 here what? 4. So our answer is what? 4x to the power of 4 plus c. Now, let's also confirm whether our answer is correct. If you have to find the derivative of this, what do? You multiply it by the power. And what do? You subtract it by 1. That will eventually give us 16x to the power of 3. So I'm sure by now you guys have understand the basic way of what? Integrating an expression. Now, what do? Let's move further. Now, what if you are told to find the antiderivative of what? A constant. That is, let's use 10 dx. So now, how do we find the antiderivative of stuff like this? Remember, we can easily rewrite this as what? 10x to the power of 0 dx. Because we all know that anything to the power of 0 is what? 1. So therefore, this will be what? 10x to the power of 0. This is same thing as 10. So what do? when you want to find the antiderivative, it will be 10x to the power of 0, we add plus 1 over 0 plus 1. Then this plus c. Now give us what 10x to the power of 1. But it is mathematically wrong for us to write our 1 here. And if you should divide it by 1 to still give us 10x, therefore our answer will be 10x plus c. This is our answer. If you should find the derivative of this, it will eventually give us 10 back. That's another way of confirming that your answer is correct. Now let's move into something a bit complex. Now it might be giving stuff like square root of x, close bracket, dx. Now, before I solve questions like this, I'm sure I've made a video on indices for you guys before, in case you don't understand it. Whenever they give you a question on antiderivative or integral calculus, always rewrite your expression in the way that it will be easy for you to find the integration of it. So this is what I'm talking about. You can easily rewrite this as what? X to the power of what? Half dx. Now, if you can find the derivative of this, it will be what? X to the power of half plus 1 over half plus 1, then plus c. Now, do we leave our answer like this? No. We move. This becomes what? X to the power of what? Half plus 1 will give us 3 over 2. So this will give us what? 3 over 2 over what? 3 over 2. We have plus c. So we can multiply both the numerator and the denominator by what? 2 over 3. Or if you do not understand it that way, you can just bring this to the other side and reverse it back. We all know how we do it then in our primary school days. So therefore this will give us what? 2 over 3. Then we have our x to the power of 3 over 2 plus c. You can leave your answer like this, or you can decide to what? This is what? Square, right? So this will become root what? X all to the power of 3 over 3 plus c. So this is our final answer for that. Now let's move to another question. Now what if you are given the integration of what? X to the power of 5 dx. Now you can feel free to pause the video and give it a try before you solve it. Okay, now that you are back, let me attempt this for you. So like I said, you always rewrite. This becomes what? X to the power of what? 5 to the bracket of what? 1 over 4, following our law of indices. So this becomes what? X to the power of 5 over 4 dx. Now what do we do? This becomes x to the power of 5 over 4 plus 1 over 5 over 4 plus 1 plus our constants. Now 5 over 4 plus 1 will give us what? That will give us 9 over 4. So this will give us x to the power of 9 over 4 over 9 over 4 plus c. Then our total answer is what? 4 over 9, then into the fourth root of what? X to the power of what? Either I can do it this way, to the power of 9. Then you add our constants to it. That's our final answer. Now you guys can take down this question where you have, let me give you a question. So your own personal assignment, which I won't be solving. Find the integral of what? Fifth root of what? X to the power of what? 7 dx. So this is your own assignment. Now, since we are done with the basic stuff of integration, let me quickly dive into exponential and then we can stop for now. So now do we solve a question dealing with exponential? So that has to do for the antiderivative of e to the power of x dx. We will use our u substitution. Once we use our u substitution, you make this u, and after making this u, you find the derivative of the u, then you divide it and you do the u over the derivative of your what? U. But now there are easy way, there's another way you can solve this faster, especially for those doing an objective question. You need to work on your speed. So now this will be what? This is what I'm talking about. When you're looking for our derivative, what do? We find the derivative of what? The x here, then we multiply it with this. Now what do you think we'll do? We find the derivative of x, of the power rather, and what? You divide it by it. So this is what you do. This will be what? E to the power of u over what? U derivative plus c. Now, e to the power of u is the normal expression, so let's write it. This will be e to the power of x over du dx of our x here. So if you find the derivative of the power here, what will it give us? It will give us 1. Then you add our constants. Therefore, it will be e to the power of x plus what? C. Now, with that being said, let me now give you just 2 questions on exponential, and we can call it a day for today. So now we have e to the power of x for the first one. So we have e to the power of x for the first one. And okay, let's do it this way. Let me clean this. So we have e to the power of what? 5x dx. That's our first question. And we have e to the power of 3x plus 5 dx. Solution. So this is what we do. Sorry I'm taking most of your time, but you have to get this basic principle before we now move into trigonometry, use substitution, and integration by parts. Now, the first question, e to the power of 5x. Following the method or the principle we shall apply here, our answer will be what? E to the power of 5x over what is the what? Derivative of 5x. That will be what? 5. And perhaps, maybe, I assume before you be able to watch this video, you must have watched our video on differentiation. If you have not done that, you should check the description button and you see the question there. So this will be what? 5. The derivative of 5x will give us 5. Then you add our what? C to it. That is all about that. Now, for the second one, you apply the same principle. So I'm going to find the derivative of what? 3x plus 5 dx. The answer will be e to the power of 3x plus 5 over what? What's the derivative of this? That will be 3 plus 0, which is still 3, plus c. So this is where I will be stopping for today on our integral calculus. Remember, we are still under our indefinite integral. So we have a long way to go on this integral calculus. So thank you very much before I stop this video, I always say if you have any question, you can always ask it on the comment section and I will respond to it. So this is where I will be stopping for today. Thank you very much. Thank you very much for watching our video. See you in our next. Kindly like and subscribe and turn on your notification bell. See you in our next class. Thank you.